All right, what is up, people? Bringing you a little preemptive Q&A here on the Classwork GA. Remember, this is due on Friday, so make sure we get this done, all right? But we're going to walk through just the questions. Have any questions on it? Hopefully, these can answer it, and then you guys can bring this in on Friday. All right, number one, which function can be used to find the length of AB? So if this is x, we want to find this. Normally, we'd look at this 40-degree angle and we would say, well, this is the adjacent. That's the hypotenuse. So we would be using well, let's do this right. AB is over here. So the opposite and the adjacent, which would be tangent from this 40-degree angle, but that's not a choice. But there is a 50-degree angle here with the other choice, and that's actually the measure of the angle A up here, which would switch the 12 and AB to opposite and adjacent. So that's kind of the idea here, okay? Which equation is true for this triangle? Essentially, all this is if you do the sine of angle A, okay, or the cosine of angle A, all right? Now, why do I know it's A? Because it's sine of A, cosine of A, tangent of A, so I know that that's my angle. Which of these is it? So if cosine of A is adjacent B over hypotenuse C, when I cross multiply, I get C times the cosine of A equals B. And then I just want to go check that against the answers and see if that's right. So just go ahead and play through those and see which one works. Given the triangle right with x the nearest foot, just another SOHCAHTOA question. Find your angle, label your sides, choose your correct trig function. Remember, side, cross multiply, angle is the inverse. For number 4, in the right triangle below, there isn't one, so draw it. Okay? Pay attention to which is the right angle. So if angle ABC, that means B is my 90-degree angle here, and then I'll put A and C as the other two angles. It doesn't really matter which is which. It says AC is 29, AB is 17. Find the measured degrees on angle BAC. That's this one. So same thing. Label your sides. Nearest degree, so round. Okay? And then what do you end up getting for that degree? Okay? This time you're looking for angles, so you're going to use the inverse. So label your sides, pick your trig function, use your inverse. For the find the length of BC, you can either use the answer from A and do another trig, or because we're using these two sides and finding BC, we could also use Pythagorean theorem. So I'll let you pick for that one. Okay, nearest inch, make sure you're around appropriately. Number 5, the trapezoid is drawn below. Calculate the measure of angle x to the nearest tenth of a degree. So what we really want here is we need the length of one of the two other sides. Remember, if this is 28 and this is 36, this extra piece is the difference between the bottom and the top. And then once you know what this is, okay, hopefully you know it by now, you can use this side across and the 12 to figure out the angle. Remember, looking for the angle, use the inverse, okay? For 6, the ladder is resting again at 15-foot ladder, resting against the wall here, okay? And it's also leaning on top of a fence, which is 6 feet high. 4 feet from the 6-foot fence. So the first thing I want you to do is find the angle where the ladder makes the ground. That's the angle right down here. So use this small triangle here and SOHCAHTOA to get the angle. And then the question down here is essentially ignoring the fence and just looking at the ladder against the wall, okay? So if we want to know how high up the side of the building is, we want to know this height right here. You already know that this piece is 15. The answer to this question will give you that angle, and you can do SOHCAHTOA again. All right. For number 7 down below, the flagpole stands on level ground. 2 cables R and S are attached to the pole 16 feet above the ground. The combined length of the 2 cables is 50, so we know that R plus S is equal to 50 feet. Okay. R is attached 12 feet away from the pole. What's the measure of angle x to the nearest degree? Now that means we need side lengths in this triangle in order to get x. Got it? Okay. So really we want to figure out what's going on here. What we do know is because we already know that this is 16 and 12, you should be able to figure out what r is first. Once you know r, you can easily find s, and then we'll have the two sides, the opposite and the hypotenuse, and that can help you get x. Okay, so that's how you're going to do number 7. Number 8. This is a tough one. Also, this is B, angle BAE. If this drifted up on yours, I apologize. All right, rectangular with a block is leaning against a vertical wall as shown below. If AB is 8, okay. Now it's rectangular. That means that this is 8. And it also means that these are 90-degree angles. And that 90-degree angle is going to come into play later on. Okay? All right, it also tells you that BC is 5. So these two pieces are also 5. All right? So we want to know, first of all, what the vertical height C is. That's the height from C all the way straight down until it's perpendicular, which is actually the same as FB. So if we're looking for the vertical height of C, we're really looking for the distance or the length of, sorry, not FB, FE, which is technically made of FB plus BE. So if we can figure out these two pieces, we'll know the length of FE and therefore the vertical height. Okay, so how do we get them? Well, we're looking strictly at these two triangles. The first one is BAE right here. So can you use 8 and the 28-degree angle to figure out that length right there? And the second one is this triangle up here, FCB. I know this is 5. I need an angle here. Keep in mind, if this is 28, you should be able to tell me this angle. And because this is 90, you should then be able to tell me the measure of that angle. Once you know FBC and the 5, you should be able to figure out what FB is, and then just add these two things together. Okay. Number 9, Andrew is at point A in a park. A deer is 3 kilometers directly north. Okay, so here is Andy. He's at point A. The deer is 3 kilometers to the north. Okay, at point, that's point D. Brian is 1.8 kilometers due west. Remember, WE for west, right? West and east. Spells we. So the west is this way. All right. And he is 1.8 kilometers away at point B. And so we want to know a diagram. Yay. Helped you out with that one. Calculate the distance between Brian and the deer, which is this length right here. Now, because it's west and north, that's a right triangle. Okay. By the way, this answer is going to seem wrong, but keep in mind the actual distance is greater than 3, okay? You're going to get a length for this, and when you actually round it, it doesn't seem right. Just go with it, okay? All right, I'm going to let you know that right now. You get an answer, you're going to be like, wait a minute, that can't be true because that would mean that, you know, something's going on with DA and DB here, but just remember, it's actually longer, we're rounding it down, okay? All right. Second thing, Brian looks at Andrew and then turns through an angle of theta to look at the deer. Brian is looking this way, and then he looks at the deer. So he's creating that angle right there. So we want to find the angle. So you already know this is 1.8 and 3. It's a right triangle. There's my acute angle. You can use SOHCAHTOA for that one. All right. Number 10. Okay, this one looks a lot harder. You got to break down the different shapes in the diagram that really help you out. Okay, in the following diagram shows a sloping roof. Surface ABCD is a rectangle. Angle ADE right here is 55 degrees. Vertical height AF is 3, and the length of DC is 7. Now keep in mind, if this is 7, so is this. Okay, we want to calculate. First thing we do is calculate AD to the nearest hundredth. So you're really focusing in on this triangle right here for that. Okay, that's the triangle we're looking at. So we have 3, 55. We want to get the length of AD here. Now, AD is important because technically it's part of this rectangle, right? A, B, C, D. I drew this at an angle, not, fit the scale, so take it as you want there. Now, we're going to figure out the length of AD in part A. So let's just call that X, okay? That's what this is going to be, that's X. We know that this is 7. So if we know this is 90 degrees. If you were to draw this out, and this is dB, how would you figure out the length of this if you have this specific shape going on right here? All right, let you guys figure that one out. Remember, you're going to know what this is. So if you know what this is and this, how do you get that? Okay. Number 11, a ladder is standing on horizontal ground. So that really this part is telling you is that with the ladder is standing and leaning against a vertical wall, that the wall is making a 90-degree angle with the ground. Ladder is leaning up against it. The length of the ladder is 4.5 meters. So that's 4.5 meters. The distance between the bottom of the ladder and the base of the wall, bottom of the ladder, base of the wall, is 2.2 meters. So not drawn to scale once again. All right. There's your diagram. Calculate the distance between the top of the ladder and the base of the wall. Top of the ladder, base of the wall. What's the distance? Okay. And calculate the obtuse angle made by the ladder with the ground. So keep in mind that in this triangle, this angle is acute. So where, oh where, might there be an obtuse angle? Gee, I don't know. Where could it be? Got it? So once you understand what this angle is, you might be able to figure out that answer. All right, that's it, guys. It's a quick vid. Go through it. Remember to like and subscribe. Just kidding. We'll see you guys on Friday. So if you guys are working this up on the weekend, and there's going to be a test next week. I'll fill you in. If you check the grade calendar, it's up there. Let me get it real quick and I can let you know. It is scheduled for Friday. All right? Just so you're all aware, keep in mind. All right, guys. Have a good one. Enjoy the rest of your little week off here, all right?